This is the second part of the video looking at solving simultaneous linear equations using the elimination method. Here we're going to look at what happens when the variable terms are not the same size. What we do is we target a variable term in each of the equations that's easy to change to the same size. We then multiply one or both of the equations by an integer to achieve the same size term, and then we're going to add or subtract the adjusted equations like before. Let's have a look at an example. So here we have two simultaneous linear equations. We've already labelled them, and you can see the x's are not the same size and neither are the y's. But it's easier to change the y terms because I'd only have to double this term and then it'd be the same size. If I had to change these terms, I'd have to multiply the 5 by a 3 and multiply the 3 by 5. So that's extra work. I'm not going to do that. So we're targeting the y. Now I want to say what I'm doing. So what I'm going to do over here, I'm going to say I'm going to multiply by 2 my second equation, which is in the circle. So I take this first term, I've got to multiply every term, so that becomes minus 6x, that becomes minus 4y if I multiply by 2, and the 9 becomes 18. So this is my new equation 2, and I'm just going to label it 2 with a dash to say that I've adjusted it. Alright, so now I have two variables, the minus 4y and the minus 4y are the same size, same sign, so I have to take away, I have to subtract. Alright, so I'm going to subtract these two equations, and I'm looking at these two. Be careful to make sure that I am. Some people like to cross out that adjusted equation so it doesn't draw your eye to it. That's probably a good idea. So we've got 5x minus 6y. And 5x minus minus, well, the minus and minus becomes a plus, so we have 11x. Now we chose to subtract to get rid of those, so they become 0. And 7 take away 18 will give us negative 11. Yeah, I forgot to say what we're doing here, so I'm going to put what we're doing. We're taking the adjusted equation 2 and the first equation, and we're subtracting them. Alright, so back to our work here. So 11x, we want x, so we divide by 11. That gives us x, and negative 11 divided by 11 is negative 1. I'm going to substitute, and I'm going to substitute into equation 1. So 5 times x will be 5 times negative 1 minus 4y equals 7. 5 times negative 1 is minus 5. And then I'm going to take that minus 5 and change its side so it becomes a positive 5 over there. So we have minus 4y equals 7 plus 5, which is 12. And finally, dividing by negative 4 to get y by itself gives us y equals negative 3. Positive divided by negative is negative 3. Now I can still check. I don't use my adjusted equation to check because it's got bigger numbers. So I'm going to check in the equation I didn't use. I used equation 1, so I have to check in equation 2. Equation 2, which I've crossed out there, is minus 3 times x. I believe x is negative 1. Minus 2 times y. I believe y is negative 3. And if we're right, that should come out to 9. So I have to do those multipliers first. A negative times a negative is a positive, and 3 times 1 is 3. And this one is a negative times a negative is a positive, and 2 times 3 is 6. And we can see we were right. Alright, so therefore, the graphs of these two would make straight lines. They would intersect at this coordinate, minus 1, minus 3. For these equations, these two original equations and the adjusted one will be true when x equals minus 1 and y equals minus 3. In our second example, we have two linear equations. We can see I've already labelled them. And the sizes of the x's and the y's are both different. So I really have to target either the x or the y term. And here there's not much difference. And if I target the x, I have to multiply this one by 5 and this one by 2. That's pretty easy to do. And if I target the y, I have to multiply the 4 by 3 and the 3 by 4. That'll give me the same size. So I guess I'm going to choose to do the y term because I can see that'll end up with the same size and opposite signs, which is adding, and it's always easier to add. So I'm going to do that. So I need to say what I'm doing. So focusing again here, I'm going to multiply the first equation by 3, and I'm going to multiply the second equation by 4, and that's going to give me 12y, and both of them the same size. So let's see how that works. So 3 times 2x is 6x. 3 times negative 4 is negative 12y. Equal sign stays lined up. 3 times 6 is 18. And that's my new equation 1. I just use the dash. Some people use a different number. And my next equation, I'm going to multiply by 4. 5x becomes 20x. 3y becomes positive 12y, which is what we wanted. Equal sign lined up. 4 times negative 11 is negative 44. And that's my new adjusted equation 2. Well, I don't have to cross these out now because I've got these clearly by themselves. Now, the same size, opposite signs, I'm going to add those two adjusted equations. I'm going to say what I'm doing over this side. This is important. People sometimes get lazy and don't do this, but it's a good idea to do it. Then it's easier to find mistakes. Adding these together, 26x. The whole reason I chose add was to eliminate those to 0. And adding these together, a plus and a minus is a minus. So my answer is going to be negative. And 18, how far away is 18 from 44? 2 to 20. Another 24, so 26, so negative 26. Dividing both sides by 26 will give us the x by itself that we want. And so x equals negative 1. Now, when I substitute here, I'm not going to substitute into my adjusted equations. They've got bigger numbers, so I'm just going to use the original. It all works, it's no problem. So 2x is 2 times negative 1 minus 4y equals 6. And I've got to do this multiply, so 2 times negative 1 is negative 2. Then I'm going to change the side of this negative 2 and change its sign. Becomes a positive 2. And minus 4y equals 8. And finally, to get y by itself, I'm going to divide by negative 4. Negative 4's disappear. Go back up the top here, leaving y equals 8 divided by negative 4 is negative 2. Now I'm going to check if I'm right. Again, using the original. I used equation 1 originally there, so I'm going to check in equation 2. Equation 2 says 5 times x, I believe x is minus 1, plus 3 times y, I believe y is negative 2. And if I'm correct, that should come out to negative 11. We're checking in this equation. Do the multipliers. That's negative 5 plus, do this multiply, negative 6. And these two signs together are different, so I can replace them with a minus, and minus 5 minus 6 is minus 11. And negative 11 equals negative 11, so we know we're right. Therefore, the graphs of these two straight lines, because they'll make straight lines, would cross at this point. xy is equal to minus 1, negative 2. And for these equations, in fact all of the equations, including the adjusted one, when x equals minus 1, and when y equals minus 2, it will make those equations true. In this last example, I'm not going to do the full solution. I'm just going to show you what happens if things aren't lined up. I need to have the x's lined up, the y's lined up, the equal sign lined up. Here that's not the case. So what I'm going to do, it's easy for me to leave this 3x positive. So I just use the rules of equations. And the rule of equations says I can move that y over here if I make it a negative y. The rules of equations also tell me, well, this positive 2, if I move it over to the other side, it becomes a negative 2. So that first equation can be rewritten, and I can flip it around. There's no problem flipping the whole thing around, as 3x minus y equals negative 2. So you can see I've flipped the whole thing around. Now the second one, I'm going to go the other way. So the x is positive. So I'm going to take this y and move it over next to the x. So when I change the side, I change the sign. So, and the 3 is fine, it's just going to stay there. So the x is there. I've moved the y term over, and I've left the 3 behind. So now you can see that's the extra step I have to do sometimes when my equations aren't lined up for me. Most of the time in Year 9 they are, but as you go through your years of study, they will mix them up on you.